Greetings to all the viewers. The session is going to cover with the intermediate chemistry and the international floor entrance and the competitive exams you are aspiring for. There, the kind of session will be very much helpful. In addition to this one, India is conducting JEE Advanced, and JEE means examination twice a year to get the admission into IIT and NIT stream, which give the technical admission over there. And the NEET exam will be conducted all across India to get the admission into that medical entrance. Medical admissions will be obtained by the NEET examination. Telangana and Andhra Pradesh government are conducting MCET examination to get the admission into the BTech stream. In addition to this one, if you're aspiring for any government organized examinations, general studies question paper will be there. General science content is available. In that, the session what we are discussing is very much helpful. Let's enter into our today's session. Here, question one is related with the Nobel Prize in the field of chemistry. The Royal Swedish Academy of Sciences has decided to award 1990 Nobel Prize in the field of chemistry towards Professor Elias James Corey, Harvard University, Cambridge, Massachusetts, United States of America, for his development of the theory and methodology of organic synthesis, right? So he developed a theory and a path in order to proceed the organic synthesis. That work was carried by Elias James Corey. So because of his outstanding contribution, he was accorded with the Nobel Prize in the field of chemistry for the year 1990. Prize for masterly development of organic synthesis. The development of the art of organic synthesis during little over 100 years has afforded efficient methods of manufacturing products such as plastics and their artificial fibers, paints and dyes. So these many compounds, so multiple applications we can find for organic synthesis, right? So by means of organic compounds can be fabricated into either plastics or else artificial fibers manufactured, paints can be synthesized, and even dyes can be synthesized by means of this organic synthetic protocol, right? Biocides and pharmaceutical products as well, right? Medical auxiliaries also composed by these organic compounds only, all of which have contributed to the high standards of living and health longevity enjoyed at least in the Western world. Okay, so because of these many conveniences we are obtaining by means of organic synthetic pathways, so that standards of living got improvised and longevity will be possible and enjoyable environment can be generated by means of this organic synthesis, whatever developed by the scientist Elias James Corey, and he is accorded with the world recognized Nobel Prize for his outstanding contributions. Prize for the mastery development of the organic synthesis. The development of art of organic synthesis during the little over 100 years afforded efficient methods of manufacturing products such as plastics and artificial fibers, paints, dyes, biocides, pharmaceutical products. These many multiple compounds started with the organic moieties only. Those synthetic protocols were developed by the scientist, all of which have contributed to the high standards of living of health, longevity, enjoyability in the Western world. So that this extent of application point of view, we can go with whatever research they carried. This year's Nobel Prize in the chemistry has been awarded to the Professor Elias J. Corey, United States of America, for his important contribution to the synthetic organic chemistry. He worked upon synthetic protocols so that he was accorded with the Nobel Prize. He has developed theories and methods that have made it possible to produce large variety of biologically highly active complicated natural products, thereby making, among other things, certain pharmaceuticals commercially valuable, right? So pharmautically potent materials, even naturally occurring compounds, and biologically active substances, all these kind of various kind of organic compounds got synthesized by means of these synthetic pathways what they developed. Cody's work has also led to the new general methods of producing, synthesizing compounds in the simpler ways, right? So whatever pathways he adopted, he established so that production and synthesis of the compounds are made in the very simpler manner. The simpler platforms got established by means of this new pathway of organic synthetic protocol. This is the way eminent work got laureated with the Nobel Prize in the field of chemistry. The background to the Elias J. Corey's success lays in the fact that strictly logical way developed the principles of what is termed as a retrosynthetic analysis. The process is called a retrosynthetic analysis. Retrosynthesis stands with whatever product we have and we are supposed to move on towards the reactant. That is the kind of retrosynthesis we can go with. This involves the starting from the planned structure of the molecule one wish to produce, the target molecule, and analyzing that bonds must be taken and simplifying structure step by step, right? So whatever complicated one is there, we are going to minimize, we are going to simplify the structure as extent as possible. On one then finds that certain fragments are already known, their structure and the synthesis already described. After working backward, in this way, from the complex to the already known, it is possible to start building, synthesizing the molecule. Retrosynthesis is the most important application point of view in the organic chemistry because our complex auxiliaries got simplified so that we will go for multi-dimensional synthesis of the new molecules. New auxiliaries will be introduced. This method has proved very amenable to the data processing, which has entailed rapid developments in the synthesis planning, combining the synthesis planning with the singular creativity. Corey has developed a new method of synthesis. New method of the synthesis got introduced over. He has produced some 100 important natural products. For example, active substance extracted from the ginkgo tree used in the folk medicine in China, right? So this is another kind of thing what he developed, so that the theory whatever developed by the scientist called Elias James Corey, so that worked a lot. And multiple applications already we are following whatever established there, so that this work is laureated in the year 1990 in the field of chemistry for his outstanding work. This is the way we can conclude the question one and move on to the question number two. Cambridge International Assessment Education. From this source, we collected the question. Some hydrocarbons are formed by the process of cracking. Cracking is applied for the hydrocarbons. State the meaning of the term cracking. What is meant by cracking to be answered? Describe the conditions needed for the cracking. What conditions are required for the cracking process to be identified? Okay, so let me answer questions one by one. First, to go with the cracking process. Cracking simply said to be cracking is applicable to the petrol. So as we already aware that petrol can be extracted from the various sources, right? So crude oil is available near to the seashore, so that we can extract that petroleum crude product over, and whatever crude petroleum is extracted further subjected to refining process. So many refining techniques are required, being it is contaminated with so many impurities. So impurities can be removed later. That process is said to be refining. Later on, we will go over fractional distillation, so that among so many fractional distillation, one of the fraction collected as a petrol. That's the reason why that is not in the sufficient quantity, so that we have to go for increasing the quantity of the petrol. In order to rise the petrol quantity, whatever long chains we already have in a petrochemistry, petroleum zeology, organic chemistry, cracking is the process that will be applied for the organic molecules, right? So whenever organic molecules were taken, long chains were taken, we are supposed to break down them, and the sufficient carbon length will be obtained, which is suitable for the petrol fraction. That is the reason why long chains may be broken so that larger extent of petrol synthesis is carried in order to meet the demand of that petrol. This is the way cracking process will be carried, and we can define the cracking either by applying the thermal conditions or else catalytic conditions. Long chain hydrocarbons, we can say heavy oil, that compound will be broken so that the required quantity, required length of carbon chain will be obtained. Required chain length of the hydrocarbons will be obtained by the process called the cracking, right? Let's go with the what are the conditions required for the cracking method. In order to go with that, thermal cracking and catalytic cracking, we can go with under thermal condition. Thermal conditions means we are rising temperature. At that elevated temperature, what happens? Even pressure is also applied over. At that elevated temperature and pressure, the long chains will be broken and petrol fraction will be generated. High pressure thermal cracking operates absolute about 7,000 kilopascals. This extent of higher pressure is required to be applied, and moreover, we have to go for 750 to 900 degrees centigrade. This extent of high temperature, high pressure and high temperature whenever applied, so that long chain heavy oil will be broken and giving rise to the petrol fraction over there. Okay, William Marion Burton developed the earliest thermal cracking process in the year 1912 at the temperature 700 to 750 degree Fahrenheit in Celsius scale, 370 to 400 degrees centigrade. So absolute pressure applied will be 90 psi and 620 kilopascals if we mention for. So this is the way conditions are provided for the cracking method. And Burton process. So here, if we are applying these conditions in particular, the process what we are cracking, what we are synthesizing the petrol, that is said to be Burton process, right? So Universal Oil Product Company will be there. Somewhat more advanced thermal cracking methods will be obtained by applying 750 to 860 degree Fahrenheit, around 400 to 460 degrees Celsius will be applied. That is called Dubs process. So that is said to be Dubs process. Dubs process used extensively by refineries in order to go for the cracking process. Catalytic cracking it will be, and in that refineries we will apply this one. This is the way we can give the conditions required for the cracking. Only the thing we need to remember is pressure is applied, at the same time temperature to be raised, then only cracking process will be possible. In the presence of catalyst also we can apply this kind of cracking process. This is the way we can answer this question number 2. Let's move on to question number 3. Sorry. This is also answered, and let's enter into the question number 3, which is collected from question number 3 is collected from 2015 paper 2, JEE advanced question paper, which is conducted by the National Testing Agency. This is the question regarded with the organic chemistry point of view. Among the following, the number of reactions that produce the benzaldehyde, where we are getting benzaldehyde to be answered. Multiple answers. So here produce a reaction or reactions. That means more than one answer might be correct regarding this kind of benzaldehyde synthesis, right? So in case of this one, first of all, let me go with the benzene. Benzene can be treated with carbon monoxide and hydrochloric acid. Whenever CO and HCl got added under anhydrous AlCl3 conditions and copper chloride, the product is expected to be benzaldehyde. Obviously, Gattermann-Koch reaction it will be. And second is regarding, this is the benzene which is having the side chain with the CHCl2. This is called dichloromethane. Let me repeat again. Dichlorophenyl methane is the compound which can be hydrolyzed at 100 degrees centigrade. Whenever hydrolysis carried on the same carbon, you can put 2-hydroxy. Chloro will be replaced with the hydroxy. Whenever 2-hydroxy will be there, 2-hydroxy are highly unstable on the same carbon. It is highly sterically strained one, so that immediately dehydrated, giving rise to the aldehyde as the product over. And this is called benzoyl chloride. Whenever benzoyl chloride was taken, hydrogen, palladium, barium sulfate, this is called Lindelof reduction. Lindelof catalyzed reduction, it will be COCl is converted into benzoyl chloride is converted into aldehyde. So Rosenman reduction it will be. And this is called benzene accompanied by the COOMe, which is called ester. Can be treated with Dibal H, which is the reducing agent. Partial reduction, you can notice. Partial reduction means ester further reduced to the aldehyde level only, but not beyond that. If further reduction, we will get hydroxy, right? So this is the way only partial reduction we can accompany by Dibal. So that 1 is giving benzaldehyde, 2 is giving, 3 is giving, 4 also giving benzaldehyde as the final product. Go with the carbon monoxide upon treating with hydrochloric acid. The entire mechanism you can go with what happens first. Protonation of carbon is protonation of oxygen is carried. Sorry, oxygen got protonated. Carbon got protonated, and oxygen is accompanied by the charge. A negative charge will be treated with AlCl3. AlCl3 will be the Lewis acid. So that Lewis acid able to form a bond with oxygen, which is indicated with the dotted line. So here you can notice the electrophilicity over the carbon. Benzene being highly rich in the electron, 6 pi electron system laying above and below of the plane, so that electron cloud is revolving around the benzene ring. Sorry. Revolving around the benzene ring, so that this carbon is having high susceptibility to bind up with this benzene. This is the way carbon is forming a new bond with the benzene ring and the origination of the carbocation. The carbocation will be delocalized in such a manner so that resonance structure is obtained and subsequent H plus removed and giving rise to the benzaldehyde as the final product. This is the reaction called Gattermann-Koch reaction. The entire detailed mechanism is provided, included with the resonating structures. So Gattermann-Koch reaction is the first one that is giving benzaldehyde as the product. Go with the second one. I'm taking toluene. Toluene is nothing but methyl benzene. Upon chlorination, 1:2 ratio we can go with. Toluene will be taken in the 1 ratio, 2 ratio of chlorine will be added. And we will substitute up to certain extent. So here, calculated amount of chlorine is required. If excessive chlorine is added, what happens? Entire 3 hydrogens will be replaced under photochemical conditions. But here, controlled conditions we are applying. Calculated amount 1:2 ratio is supposed to be added so that we will get a dichloro methyl benzene. This is starting material what actually we got in the question, which is subsequently added with water at the temperature 373 Kelvin. Whenever 373 Kelvin means what 100 degrees centigrade temperature is applied. Just we are boiling water. Whenever water boiled with this compound, what happens? 2-chloro will be replaced with OH. That will give the gem dihydroxy compound. 2-hydroxy and the same carbon will face the high repulsive interaction, so that immediate dehydration giving rise to the aldehyde as the product. This is the way benzaldehyde is the final product in the option number 2 as well. Let's go with this benzoyl chloride. Benzoyl chloride is treated with hydrogen, palladium, barium sulfate that is provided here. This is called benzoyl chloride. Benzoyl chloride, hydrogen, palladium, barium sulfate, that reaction is a named reaction. We can see Rosenman reduction. It will be whatever aldehyde, whatever chloro is there, that simply replaced with a hydrogen in the presence of linear catalyst, and the output product will be benzaldehyde. This is the way Rosenman reduction is carried by palladium in the presence of barium sulfate. The final product is expected to be benzaldehyde. So this is the way third is also able to accomplish benzaldehyde as the product. Let me go with the ester. Ester reaction with, it is clearly mentioned, I'm taking instead of benzene here, methyl is provided, but it is not the matter. You can go with, let me assume this is the ester. Sorry, this R might be a benzene ring. Let me assume this R might be a benzene ring, and this is the kind of ester. Ester compound treated with Dibal. Dibal is the kind of mild reducing agent. Up to certain extent, reduction is possible. This will be end up with the aldehyde compound. Even nitrile is taken, that also giving aldehyde as the final product. This is the way either ester or nitrile is able to give the aldehyde as the final product. So Dibal is the kind of reducing agent can conveniently convert ester into aldehyde. So that for question 3, you may go with Getterman-Koch or else hydrolysis of a dichloro compound or else a benzoyl chloride, a Rosenman reduction or else ester partial reduction with the Dibal. All are giving rise to the benzaldehyde as the final output. So this is the way we can answer question number 3. Let me go with the question number 4. Question number 4 is collected from 2015 paper 2 conducted by the National Testing Agency. JEE advanced question it is. In the complex acetyl bromido dicarbonyl bis triethylphosphine iron 2, the number of iron carbon bonds are, how many iron carbon bonds are to be identified? In order to identify, iron carbon bonds are required. So the complex is provided here. The central iron is surrounded with the set of ligands. Over there, you can notice the carbonyls are 2, and here acetyl is there, and triethylphosphine is there. How many? 2 triethylphosphines are there. 1 bromo will be there. If this is the condition, how many metal carbon bonds you can locate? Iron carbon bonds are present between iron metal and carbon atoms. One with the COCH3. Here carbon directly linked up with this iron, that is 1. And here carbonyl groups will be there. What are carbonyl? CO is called carbonyl, right? In that also carbon with iron. So that 1, 2, 3. The possible iron carbon bonds are 3 in this molecule. So if we observe this octahedral structure, then it is possible to identify how many iron carbon bonds are present in the given complex. 2 are triethylphosphines, 1 is acetyl, 1 is bromo, 2 are carbonyls. In that, 3 carbons are directly linked up with the iron. 3 is the right answer for question number 4. Let me go with the question number 5. It is collected from 2020 MSET examination conducted by the Telangana government. The correct set of symbols of the molecular orbitals given below. ఈ క్రింద ఇవ్వబడిన అణు ఆర్బిటాల్ల యొక్క సరైన చిహ్నాల సమితిని కనుగొనండి. So this is the orbital where 2 dots joined with the these lobes. And here we have a bonding orientation. This is anti-bonding orientation. And this is a kind of bonding orientation. This is a lateral overlapping. This is called axial overlapping. This is called lateral overlapping. Lateral means top and bottom, above the plane and below the plane. On the plane, if observation is there, that is called axial overlapping. So these many possibilities if present, then what is the correct representation we have to go with them. First is called what? First one is called pi star. This is the kind of representation indicated for pi star orbital. And the second one, able to axial overlapping giving rise to the sigma bond always. Second bond is called sigma bond. And third is called sigma star. Sigma star means 2 opposite lobes. If you observe it clearly, 2 opposite lobes are combining, so that sigma star it will be. And here pi. So here pi bond will be there. So this is the way we can clearly answer all the questions, and we completed. This is pi star, sigma star, and pi bond will be there. Question 5 concluded, and reached question 6. Equal amount of 2 gases, molecular weights 4 and 40 are mixed. The pressure of the mixture 1.1, and what will be the partial pressure of the lighter gas in the mixture? అనుభారాలు 4 మరియు 40గా కలిగిన 2 వాయువులను సమాన పరిమాణంలో కలిపితే ఆ మిశ్రమం యొక్క పీడనం 1.1 అవుతుంది. అయితే దానిలోని తేలికైన వాయువు యొక్క పాక్షిక పీడనం ఎంత? Okay, so partial pressure to be identified for the 1 fraction, right? So among all, the correct option will be 1 atmosphere, that is given in the option number 4. So at that condition, use Dalton's law of partial pressures. Okay, so here total mass is considered as M. Mass of total gaseous mixture is said to be M. Total moles of gases, how many moles of gases added? Mass by The first fraction given is 40, molecular weight is 4, and mass by the individual, its a fraction molecular weight is given by 40. If we add these two, so the total moles we will obtain. So since no reaction is happening, number of moles proportional to the partial pressures. Okay, so here we are not reacting these gases. That's the reason why how many moles are there, that extent to partial pressures will be there. M plus 4 plus M plus 40. If you take the ratio that is taken in the 10:1 ratio. So here M by 4 is given for what? First gas number 1, and M by 40 is given for gas number 2. The partial pressure of which gas? The partial high the mixture, what will be the partial pressure of the lighter gas? So lightweight gas partial pressure to be identified. Always gas amount will be measured in its pressure only. If you are taking a solution, in that concentration matters, but in case of gases, pressure only matters. Lesser the pressure indicates, lighter the material will be. If you are taking two gaseous mixture are existing in the ratio of 10:1, so lighter fraction is nothing but which is in the least proportion. So that obviously 1 atmosphere will be the fractional or partial pressure for that lighter element. So this is the way we can answer. 1 atmospheric pressure is given. So this is the way question number 6 got concluded. By this, we covered the entire session where different segments of the chemistry got covered over. And we gone through the various segments included with the application point of view. Nobel Prize accorded in the field of organic synthetic pathway. In addition to that one, problem solving analogy gone through. Organic chemistry problems are solved. Physical chemistry, inorganic, everywhere. So here coordination compounds. So many valuable segments are covered, and authentic information is collected from the various websites, so that I'm requesting you to like the channel. And in order to comment here, we have a question for the session. The question is, in order to comment, the question is related with the petrol. Can you give the chemical composition of the petrol? Okay, I'm not asking about all the fractions of petroleum oil. Rather, I'm only asking about the composition of petrol. That to be mentioned in the comment box for the session, and share with the aspirants who are more serious about the examinations. And subscribe the channel. Definitely, we will come up with the new content in the near future. Thank you for your consistent listening. Thank you, one and all.